Imagine waking up tomorrow and discovering that satellites no longer exist. Your phone cannot find your location. Airplanes are grounded. Global internet connections collapse. Weather forecasts become unreliable. Financial systems slow down. Within hours, modern civilization would feel the impact. Satellites are invisible to most people, yet they are among the most critical technologies humanity has ever built. They quietly orbit the planet, forming the hidden infrastructure that keeps our world connected, informed, and synchronized. For decades, satellite technology evolved slowly, controlled by a small number of governments and massive institutions. But that era is ending. Today, satellite technology is entering a period of rapid transformation, one that will fundamentally reshape how humanity communicates, navigates, produces food, responds to disasters, and understands the planet itself. To understand why this matters, we need to look at how satellites actually shape daily life. Every time you use GPS, you are relying on a precise network of satellites orbiting Earth. These systems provide location accuracy down to a few meters, and in some applications, even centimeters. This level of precision is essential for modern aviation, shipping, emergency response, and increasingly, autonomous systems. Self-driving cars, drone deliveries, and smart logistics networks all depend on satellite-based positioning. Without satellites, global transportation would slow to a crawl. But navigation is only one piece of the puzzle. Satellites are also the backbone of global communication. They connect remote regions, ships at sea, aircraft in flight, and communities far from traditional infrastructure. In many parts of the world, satellites are the only reason internet access exists at all. This connectivity gap is now shrinking rapidly. A new generation of low Earth orbit satellite networks is being deployed at unprecedented speed. Unlike traditional satellites positioned far above the planet, these systems rely on thousands of smaller satellites operating closer to Earth. This dramatically reduces latency and increases bandwidth. The result is near-global high-speed internet coverage. For the first time, geographic isolation is no longer a permanent barrier to participation in the digital economy. Education, telemedicine, remote work, and global commerce are expanding into regions that were once disconnected. But satellite technology is not only transforming communication, it is revolutionizing how we observe Earth. Modern Earth observation satellites monitor weather systems in real time, tracking hurricanes, typhoons, wildfires, floods, and droughts as they develop. Early warning systems powered by satellite data allow governments and emergency services to act faster, coordinate responses, and save lives. In a warming world where extreme weather events are becoming more frequent, this capability is not optional. It is essential. Agriculture is another area undergoing quiet transformation. High-resolution satellite imagery allows farmers to monitor crop health, soil moisture, nutrient levels, and irrigation efficiency from space. This enables precision agriculture, reducing waste while increasing yields. For a growing global population, satellite-driven farming could become one of the most important tools for food security. Environmental monitoring has also reached a scale never before possible. Satellites track deforestation, glacier melt, ocean temperatures, air pollution, and biodiversity loss across the entire planet. For the first time in human history, Earth can be observed as a single interconnected system. This data is not only scientific, it is political, economic, and strategic. Decisions about energy, conservation, urban planning, and climate policy increasingly rely on satellite intelligence. Behind all of this lies a deeper transformation. Satellite data is becoming fuel for artificial intelligence. Machine learning systems analyze massive streams of orbital data to detect patterns, predict outcomes, and optimize complex systems. Traffic flows, supply chains, energy grids, and environmental risks are now modeled using satellite intelligence. This convergence of space technology and AI is creating capabilities that did not exist even 10 years ago. But rapid expansion brings challenges. The number of satellites in orbit is growing at an exponential rate. Space congestion and orbital debris pose serious risks. A collision between satellites can generate thousands of fragments, threatening entire orbital regions. Managing space sustainably will require international coordination, new regulations, and advanced tracking systems. There are also geopolitical considerations. Satellites are strategic assets. They influence national security, economic competitiveness, and information control. As more actors enter space, questions of governance, access, and responsibility become increasingly complex. The next decade will be critical. How humanity manages satellite infrastructure will shape whether space remains a shared resource or becomes a contested domain. What is clear is this: satellites are no longer background technology. They are becoming the nervous system of global civilization. From communication and navigation to climate monitoring and artificial intelligence, the future of humanity is being built not only on Earth, but in orbit. Understanding satellite technology is no longer optional. It is essential to understanding the world we are creating. If you want to stay ahead of the technologies shaping tomorrow and understand how they will impact your life, make sure to subscribe to the channel. This is Tomorrow Explained.